I would use a pen. But that's me. So, first and foremost, let's write step 1. And this is going to be the formation of I don't care. I don't care. Yeah. Alright, so first things first. So step 1, diatomic. Now, some of you guys are like, what does diatomic mean? So di means 2, and then atomic means atom. So diatomic means 2 oxygens, right? So diatomic oxygen is split by UV to form 2 atoms of oxygen. 2 separate atoms of oxygen. Okay, so step 1. So what I want us to do is, I think the white marshmallows are best for this. Okay, so I'm going to make a diatomic oxygen, and I've got a toothpick there, and that could be my bond. Okay, and so I don't like them when they're really long like that, so I always like to break them in half, because when they're really long it's kind of weird. So I'm going to make diatomic oxygen.
You want to use like the same colors? Or?
Yes, yes I do. So there's my diatomic oxygen, and let me go ahead and label it as O2. Okay, now the sun beaming down, right? And so I'm going to get UV rays, specifically UVB and UVC. So UVB and UVC is going to break my oxygen molecule. And by the way, this is the oxygen molecule that we use for respiration. Okay, O2. That's the one that we think of. And when I break that bond, I'm going to get 2 oxygens. I mean, they're broken. The bond is broken, right? Okay, so O plus O, right?
I got a question. So we can't breathe O3?
Right. We don't. Our bodies don't use O3. All right. And so there's your first picture. So go ahead and take that first picture. And that's what we have our big paper, because we're going to be using different parts of the big paper. If that makes any sense. Yes. So this picture is going to go right here. Okay. So as your step 1. Yes. So we're just taking it slow, right? Alright, so that was step 1. And now we're going to go on to step 2. Okay? Now all of this is normal. Bear in mind, this is just what's normally happening in the stratosphere, okay? So we haven't gotten to the weird, the human-made issues yet. So these free oxygen atoms, these guys right here, so free,
so this is step 2.
This is step 2. Free oxygen atom binds with a diatomic oxygen to form ozone. Alright, so let's demonstrate that. So I'm going to grab one of these, right? So I've got plenty. So I'm just going to grab one out of my bag. So my free oxygen okay, and I'm going to go ahead and bind it with a diatomic oxygen. So diatomic means that there are two, right? You guys with me, or are you guys talking? I don't want you to be confused later. Alright. And now that those are binding, I'm going to go ahead and make ozone. Now, ozone has how many oxygens? Say that again.
She said 3.
Very good. And you could tell because I've got 1, 2, 3. So, right?
So how we gonna make that?
So how are we going to make that? Alright, so it kind of goes like this. And it looks like a triangle. We call it a triangular planar, but that was from chemistry. So I don't want to confuse you since it's been a good minute since chemistry. And so ozone kind of looks like that. Okay, so finally now in my ozone layer, I now have O3. How are we doing so far?
I gotta catch up.
So once you've got step 2 written down and done, take that picture and that goes on the next slide. And you can put these in the slides when we're all done. Like, you don't have to do it as we go. Does that make sense? That's not necessary.
I just drew them. Honestly, I didn't put the marshmallows down. I'm gonna need it.
I thought it was
I'm gonna need like it.
Let's see, that's another picture right there.
What do you mean? That's what the marshmallows are for, to give you a visual. Does that not help?
Not really, because I mean they're gonna be off the paper in a minute. I mean, we're taking pictures of it.
I mean, I was just trying to help you find a visual.
What did you say? Still can't hear you.
I mean, even my AP kids struggle with this concept, so that's why I was like, well, we need to take this slowly. Even with my AP kids, we draw it. We draw pictures of it. We draw circles. This concept, yeah. It's still confusing for them. So, you're not the only ones that get confused by this stuff. Alright, so this is all the normal stuff that happens, okay? So this is how we're going to form O3 in the stratosphere. Does that kind of make sense? We're good?
Okay, so I take a picture. Is this step 2 or like step 1 and step 2?
You should have 2 different pictures right now. One of step 1 and one of step 2. Alright. So, step 2. Now we're going to move on to the bad stuff, to the depletion of stratospheric ozone. So the stuff that we human beings do. Alright, so I'm going to take my marshmallows off real quick. So I'm just going to move them off my paper, and I'm going to get some more white space. So for me, I'm just going to switch paper, but you've got a huge sheet of paper, so you should be okay. I'm not worried about you guys not having enough paper. So stratospheric ozone depletion. Alright, so of course this has to go in steps, right? Like we did before. So step 1. Step 1, I'm going to give you a chlorofluorocarbon that has 3 fluorides and 1 chloride, because that's easiest. Chlorofluorocarbons can have differing numbers of chlorides and fluorides. So, but the one I'm going to give you is going to look like this. Okay, so I've got CClF3. That means I've got 1 carbon, okay, 1 chlorine, and guess how many fluorines I have?
3.
3. All right. All right. Here's what happens. UV light.
Now, so you can go ahead and explain. I just got to be right.
So when these molecules go into the stratosphere, so remember these are man-made, completely man-made. When they go into the atmosphere, all the way up in the stratosphere, UV light, so remember UVB and UVC, right, are going to react with chlorofluorocarbons. And when they do, what you get out of that is you're going to get CF3 plus a CO. Alright, so let's go ahead and let's get our colored marshmallows, and I think everyone's got the right proportions. And so we'll get 3 yellows, and then we'll get a red or pink, whatever, and then we'll get a green. I'll give you guys a minute. Okay, so again, I like to break my toothpicks in half just because I don't like them being big like that. So I like to break them in half. And so I'm going to make this pink one my carbon. Carbon forms 4 bonds. We know this from chemistry. So carbon forms 4 bonds. That means that carbon's going to be the middle atom. Okay, so I'm going to go ahead and put those covalent bonds in for carbon. Alright, so there's carbon. Now, these are going to be my fluorides. Okay, so I'm going to go ahead and put them in. It really doesn't matter where. Really, this would look a little bit different if we were actually doing the actual molecule. And so this is the chlorine. Okay? So really the molecule kind of looks like this. Like it could stand kind of like that.
4 yellows and 1 pink. 3 yellows. 1 pink and then
okay, so here's my carbon in the middle, right? These are my fluorides. Okay? And this is my 1 chlorine. Alright, so what happens here is that the sun is going to go ahead and break this bond here. Okay, so the UV, B or C, one or the other, is going to break this bond there. Okay? So then, what do I get? And hopefully you've got enough yellows to make this happen. Okay? So what you get, so I've got this carbon, and it's not a very happy carbon, because carbon absolutely wants to make 4 bonds. So it's not a happy carbon. I'll put the bag out in case you guys don't have enough of a certain color. But let me finish this real quick. So you end up
He said, oh, snap.
So this is my CO right here. Let me put that bag out just in case you guys run out of certain colors. It's entirely possible. Okay, I'm going to put the bag out. So if you run out of a color, you can come and grab it. Give me 1 moment. Here's some colored marshmallows. In case you get to a place where you don't have a certain color, okay? Just try not to stick. That's kind of right. Okay? I'm sorry? Yeah, but I wanted to talk about it a bit. Alright, so this is my chlorine, and it's detached from the chlorofluorocarbon, right? The sun has detached it, has broken it off, okay? And so now this chlorine, who's very, 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 very active, very reactive, is now able to go out and attach to something else. Okay, so let me write this in words so you know what to put. Okay, so UV from the sun splits your chlorofluorocarbon to CF3 plus CO. Okay? Alright, so all of that is your step 1 for stratospheric depletion. Oops, let me make that a little bit, there you go. Okay? Okay, take that picture, and we're moving on to step 2. So now we have this. We call this a free radical. Or a catalyst. And so I'm going to explain that in just a minute.
What you want to, I can't, like, what that say up here?
A free radical or catalyst. Okay? Take that picture. That's your step 1.
What about the bottom? Like, I'm gonna need all that too?
Yes. So there's your step 1. Let's move on to step 2. Radical, R-A-D-I-C-A-L, radical. And then catalyst, C-A-T-A-L-Y, S-T, catalyst. Okay. Scoot on down on your big sheet of paper. We only got 2 more steps to go, and then you guys can eat these things. 2 more steps to go. All right, so
Wait, so we flip it over now?
stratosphere. I'm writing it again. You don't have to. It's only because I'm switching papers. So that's the only reason why I'm writing it again. All right, so step 2. All right, so now I've got this free radical, as I stated before, so that's that Cl. And that Cl is going to attach itself to the ozone in the stratosphere, my ozone. So I'm going to grab my ozone. I already made it, so I'm not particularly worried about making it again. But you can make it again if you need to. Okay, so my Cl is going to, my chlorine there, is going to attach itself to my ozone. And it's going to pluck off one of the oxygens. So then I'm going to get chlorine monoxide. Okay? So let me make that. Oops. I dropped a marshmallow. That's gross. Okay? So if I pluck off an oxygen, from ozone, what do I get? What's left over? 2 oxygens. So that diatomic oxygen, right? Which would be great if, you know, we needed more breathing oxygen. But it's in the stratosphere, and we don't live in the stratosphere, so that's not even helpful. Okay? So now I've just destroyed ozone. This is no longer ozone, right? So this is not going to help us with regards to absorbing UV rays from the sun. Does that kind of make sense? Okay, so I've just plucked off an oxygen from ozone, from O3. Okay, and so now I've got ClO, right? And then I've got O2. Okay, this is not helpful at all in the stratosphere. Now, honestly, there's another step, because what's really frustrating is this chlorine will get plucked off of this oxygen, and so then it becomes a free radical again, so it can do it all over again. So let's do step 3. But first, let me write this down. So the free radical, so I'm just describing step 1. Step 2, sorry. The free radical attaches to O3, and then it forms ClO and O2. Alright, so moving on to my step 3. Moving on. I'm going to take this guy right here, this chlorine monoxide. This is step 3. You can just hold on. You can take your pictures in just a minute. So let me go ahead and take this chlorine monoxide, so ClO, right? And I'm going to go ahead and react it, or I'm going to combine it. I'm sorry, not combine it. I'm going to let it react with one free oxygen atom.
This is the last step, like.
Am I boring you?
Like, this is, no, I'm saying, because, I gotta put this back, you know that.
What?
Run out of the room with this last step.
Oh, yes. I thought you said something about air conditioning. I was like, oh, joke. I can't help you with that one. All right, so let me go ahead and make another chloromonoxide. Okay, and then all I need is one free oxygen, right? What do you think is going to happen now?
I don't even.
You don't even. What do you think?
So there's going to be 2 oxygen.
Good. So I'm going to combine these 2 oxygens. And so when I combine these 2 oxygens, I'll just have Cl by itself, right? Okay, so let me do that. So I get Cl by itself plus O2. All right, so let me make an O2. So here's Cl by itself, right? And then let me go ahead and make an O2.
Yeah, I know.
All right. Now, I've just made another, are you guys listening?
Yeah.
I've just made another Cl radical. That means that it can go and do this reaction again.
What you mean?
So we can.
It can do this over and over constantly. Okay, so now that I've made it, so look at this one. Notice this is one of my products. So my chlorine's one of my products here, but here it's one of the reactants, right? So now that I have freed chlorine up, now this chlorine can go back and do that again. And it can pluck off another oxygen from another ozone. And it can continuously do it over and over and over again.
And that's why it was destroying it so rapidly?
Correct. So this one chlorine radical can destroy up to 100,000 O3 molecules. So here's my explanation. Chlorine monoxide reacts with oxygen and forms, guys, are you listening? And forms another chlorine radical, right? Free radical plus diatomic oxygen. So that's your explanation. So this reaction occurs over and over and over again. All right, take your picture of step 2.
Wait, do we take a picture like step 2 and 3 together? Since you see that arrow going up.
No. You could take one picture of step 2, and then when you take your picture of step 3, you could take them both together, like that, okay?
I was gonna take the whole thing. No, you don't want that. Can I post both of Can I post the same picture 2 times?
If it makes you happy.
Yeah. Oh.
Two, step 3.
No, I probably do the Tuesday. No, Tuesday. I'm not saying, that's on my phone now.
Okay, are we good? Guys, are we good?
Yeah, we good.
Okay, last part. Shh. Last part.
Last part.
Yeah, a little bit of writing.
Oh, so they don't watch those now?
No marshmallows, a little bit of writing. Shh. All right, so to help you with your summary, here's what's happening. That chlorine free radical, you should be writing. Dante, go back and write. Yeah, just whatever little space you have left, okay? It's not going to be much. Okay, so that's chlorine free radical. Okay, that chlorine free radical acts as what we call a catalyst. Okay, so it acts as a catalyst. And so let me define the word catalyst for you. Okay, so that's a substance that increases the speed of a chemical reaction but is not used up. So a substance that aids in a chemical reaction but is not used up. Okay, so that's what a catalyst is. So your chlorine free radical acts like it's a catalyst. So that chlorine free radical continues to break down the ozone, so O3, over and over and over again until you get a thinning of the layer. And with less ozone, the ozone layer
Where's the S3?
Right there.
Above the others.
So chlorine, your chlorine-free radical continues to break down O3, and with less O3, the ozone layer begins to thin. And so we get that hole, we call it a hole in the ozone layer. So what happens? That means the ozone layer cannot absorb what?
It can't absorb UV light.
Very good.
Okay, boy. What? Super smart.
Specifically, UVB, and UVC. That's a U. We know that when that radiation hits to Earth, that it can cause destruction to our DNA, which can lead to cancer and cataracts. Cataracts is yes, slow deterioration of, I believe it's the retina of the eye. Yes. And can also disrupt the photosynthetic parts of plants and algae. So, with that, oh man, with that, guys, that last, this part, so, just kind of looking at this last part, if you guys would just look at the little GIF, we basically just did this, alright, so, here's the CFC, UV radiation knocks off the chlorine knocks off an oxygen.
Oh, okay, that makes sense now.
So if you guys would just kind of look up UV radiation knocks off the chlorine, okay, that chlorine's going to react with another oxygen, and now the chlorine's free to do it
It
again.
just makes a whole bunch of, like, sets, pretty much.
It basically makes a whole lot of O2, right?
Yeah,
And that can't block UV light.
Correct.
and we don't breathe that, right?
We do breathe O2,
Oh,
but we don't live in the stratosphere. But we don't live in the stratosphere, right? So that's not really helpful to us that it's making O2. Okay, so that's the way that works. So what I want you to do is write your summary. We just kind of went over it. You know, write it in complete sentences, not the way Ms. Johnson wrote it. Okay, so write it in complete sentences so that you can show me that you get it. And you can kind of watch the GIF as you write because the GIF is helpful, right?
Dante, it was a small deal. Bro, you just can't do all that.
we don't need to write the summary on the paper, just get the thing.
Right.
Okay.
All right. Hey, so guys, when I go through to grade, I expect to see a picture here with the next, and a picture here, and a picture here, and a picture here, picture here, and then a summary. So let's get that done.
Alright, and then you need the summary at the end.
Yes.
So you need 1, 2, 1, 2, and then that's it.
All right. So let me stop recording myself. That's done.